Hey everybody, it's Tony from Adafruit, and I wanted to do a stream on an interesting piece of software called MicroPython. And it's basically a small distribution of Python that can run on little microcontrollers. And not necessarily like an Arduino, but a little more powerful microcontroller. Which is a really cool idea though, because it lets you use a high level programming language like Python, but on a small little embedded board. So, if you want to get your feet wet with embedded development and looking at Arduino and, C and C++ might be a little bit daunting for some people, it's a great option to just get started really quickly and easily. And I wanted to highlight a really interesting thing that's kind of been a recent change. So MicroPython, they had this excellent Kickstarter to support the ESP8266 Wi-Fi microcontroller. And I wanted to dig into this live stream and actually play with that and see what's the progress so far and how much support do they have with the little ESP8266 board. So let's just kind of dive in here and we'll get started. Let's see, I'll jump to the desktop and the bench view here. So kind of got everything here. And basically this is the website, and once this video goes up on YouTube, I'll put a link in the description below to all the websites that I mentioned here, but micropython.org is kind of the main website to go to get all the information on the project. And from what I've seen, it's an excellent project. Like, it supports a lot of different platforms. So I believe there was something called the Pi board as like an early Kickstarter that was a little Cortex M4, I think, microprocessors, something from ST Micro. That gives you a bunch of little I/O, things that you can control using MicroPython. And the really impressive thing with MicroPython is that they've been able to take the Python interpreter, and they've basically implemented it in a small enough package that can fit on these small little microcontrollers that only have maybe a megabyte or so of flash storage and just kilobytes of memory. So really cool what they've done. And then we'll kind of look more at the project, but they've got a really nice architecture to support lots of different hardware, and so that's why things like the ESP8266, they can bring those on and start supporting them pretty easily. But you can go to the web page here, and this kind of mentions a little bit about, I think, their first Kickstarter to do the Pi board. And then the thing that I wanted to dig into is the ESP8266. And so this was a second Kickstarter that MicroPython had, and it just finished like maybe less than a month ago. And luckily it smashed all of its funding goals. It got way more than they expected. So it looks like there's a lot of cool stuff they're going to do. But you can find out some details on their Kickstarter here. They've got a little video that talks about what they're trying to do. And the basic goal is to take a little board, like this guy. This is the Huzzah, the Feather Huzzah ESP8266. But you could even use, just a raw ESP8266 board. Take that board and let you run MicroPython on it, and not just run MicroPython, but actually support all the functionality of the board. So things like, talking to I2C devices, using the Wi-Fi radio on the chip, so, connecting to a Wi-Fi network, talking to devices, using basic socket programming, that type of stuff, all from within MicroPython, which I think is really cool and pretty powerful, especially for like building a little IoT gadget, because these little ESP boards, are pretty inexpensive, like around 10 bucks or so sometimes. And so just using one of those, putting some basic Python code on there to like read a sensor and maybe send that data somewhere could be really powerful. Now it's still pretty early on into their campaign as far as like implementing everything, and you can see here they talk about at all the different levels of funding what they would unlock, and I think pretty much everything it looks like is unlocked. Maybe this final stretch goal, I'm not sure how much they got there. So they're going to do quite a lot of support. And the really cool thing too is that a lot of this development is all in the open on GitHub. Eventually I think they're going to, everything's going to be up on GitHub. But they're also giving some of the backers of the project kind of early access to the firmware. And I did back the project, so one thing I'll play with on the stream, we can look at some of the early firmware that they've sent out already for this. But it looks great. So they're going to support like lots of little sensors, like the DHT sensor is a real popular one, temperature and humidity sensor, but other little sensors, like an accelerometer, the LSM303, lots of cool stuff there is planned. Looks like a micro database. That'd be kind of cool to store some data on the chip. The other thing that I thought was kind of interesting, let's see, where was this mentioned? I guess they don't mention it much here, but there's a little web like control application they're working on for the board, so that you can load up a board with MicroPython, and then you can connect to it as a wireless access point and open a web page and actually see a little Python console that you can talk to control the board. So lots of cool stuff that I think they have planned for this, and I think it's going to be a really neat project once everything is all finished. So we can kind of dive in and play around with this. And one thing I'll mention too, so about a year ago I did a guide on how to use MicroPython on the ESP8266 because you've actually been able to use it for quite a while. For over the last year they had a pull request that kind of pushed in basic support for the ESP8266, and then this Kickstarter now is fleshing it all out to make it a lot more, support all the functionality of the board. But I did a guide about a year ago that just talks about how to build the firmware and flash it onto the board. And I went through the guide again, and it's mostly correct, and I'll show you. I made a few tweaks because some things have changed over the last year as far as building it. But the way it works is you can use a little virtual machine using a tool called Vagrant that'll make a virtual machine, and that can install a cross compiler because you need to be able to compile code for the little ESP8266 CPU, and it's kind of a funky architecture. It's this extensa CPU architecture that's not, it's not necessarily as common as like ARM Cortex processors. So you need a special version of GCC and some special tools. The nice thing is, by doing this in a little Vagrant VM, you can run this on anything. So like I'm running on a Mac OS X, but you can run this on Windows, you can run this on Linux, and you don't need to know about, okay, when I'm doing a cross compiler on OS X, I need to homebrew, install all these crazy packages. Forget all that junk. Install a little Linux VM, and everything will be the same in that Linux VM. So you'll just use kind of the Linux way of compiling stuff. And a lot of it is really automated, so it's pretty simple and easy to follow. So we can kind of just dive in and see how this works. So what I'll do is we'll follow the guide here, and some of it is like a long compilation process that I'll skip. I've kind of done that ahead of time, but I'll show you the commands to run. We'll build the latest MicroPython firmware. We'll flash it onto the board. So up in the corner up here, this is actually a little feather huzzah ESP8266, and I have it connected to an LED, and I just have a wire that we'll use as a GPIO input, and we can kind of move that between high and low levels to show just like reading and writing GPIO on the board. So we'll play with that, and then we'll also play with kind of the alpha firmware that I just got an email for that has some of the early like web REPL. REPL is the read, evaluate, print loop. It's kind of like the command prompt in Python. So they have an early version of that we can kind of play with, and I'll show you what it looks like. And so we'll just kind of dive in here and get going. So in the guide here, it talks about what it is. So for building the firmware, now I put a link in here to a version of the firmware that's really old now, and I'm thinking I should probably just pull this out of the guide because this firmware is like over a year old now, probably, or almost a year old. So you probably don't want to do this, but what you want to do is follow the rest of the guide where I tell you how to create this little virtual machine and compile your own firmware. And it's really not that difficult. Sometimes I remember, especially early on, I'd get really concerned compiling code, and it's like, oh gosh, everything's gonna break, it's not gonna work. But it's really not too bad when you're using a virtual machine like this. Everything can be kind of installed into a known environment, so usually you have less problems there. So to get going, what you want to do is clone this repository that I have. And this just has a Vagrant configuration file. And so Vagrant is a really nice little piece of software that basically is a wrapper around virtual machines. So it lets you create a virtual machine really easily, lets you connect to a virtual machine, and it actually doesn't do the virtualization itself. So you have to also install a tool called VirtualBox, which is a free version of virtualization software, so you can run like an operating system on top of your operating system. Vagrant, it supports VirtualBox. It also supports like some commercial ones, VMware I think is a popular one. So whatever virtualization software you have, it can usually work with it. And the easy thing is, so you just want to clone this and then go into the directory, and I'm actually already there, I've already cloned it. And then you just want to run the vagrant up command. And the first time you run this, it's going to take about 10 minutes or so because it will actually download a version of the Ubuntu operating system. I think if I remember correctly, it's 14.04 that I'm using here. So it downloads that, it gets it set up, it'll load it, then Vagrant will automatically configure it so that you can just SSH right into it. You don't have to worry about a lot of the pain of connecting to a machine. So it's pretty quick. And then the second time, so I'm running this another time now, and it's a lot quicker. So you can see it just boots it up in about a minute or two. So okay, now my VM is running, and I need to connect to it. And when you use Vagrant, usually your virtual machine doesn't have a graphical interface. It's more optimized around doing kind of just console level stuff, which is great because we're just compiling code. Like, we don't need to get in here and play with X windows and stuff. So let's do Vagrant SSH, and this will connect into our virtual machine. And in just a second, so now we see this is kind of the Ubuntu prompt, and now I'm in a real Linux machine, so I can run any kind of Linux command. Like, this is Ubuntu, so you can do apt-get install stuff. And then to go forward with compiling the code, the first thing you need to do is compile the ESP Open SDK. So this gives you the compiler that you need to compile code for the ESP8266 board. And it's pretty easy. So the virtual machine image that I show in the guide here will automatically clone the repository for this. So you just need to go into the directory and just run this make command to do the installation or to compile all the code. So we'll go into the directory, and then you just want to do make standalone equals yes. The standalone version, I believe, installs it into like a little local directory that you can reference. I can't remember exactly what it does, but from what I remember, you have to do the standalone option. Now I'm not going to run this. This takes about like 20 minutes or so because it actually downloads the source for the Extensa compiler that they're using, which I think is just a modified version of GCC, and it builds it. And even though this is like a modern quad-core machine, it's compiling GCC takes about 20 minutes or so. So I won't go through that process here, but it's pretty much fire and forget. You run it, and I mentioned in the guide here, if you see a weird error like this where the LD terminated with a signal 9. I ran into this early on, where basically it kind of means that GCC ran out of memory as it was trying to compile the code. And so I kind of mentioned that you might need to bump up the memory that your CPU, that your virtual machine has. So it's a little easy config tweak you can make. I think by default I have the VM set up to use 1 GB of memory, so it seems like it's okay. When I compiled it, it seemed like it worked. So just something to watch out for there. And once it's done, then it'll basically end with this command that says, okay, it's installed and its headers are merged into the tool chain. And then what you need to do is you need to add it to the path, so that when the MicroPython firmware is compiled, it can find its compiler. And so it's really easy to do that. I just give a little echo command here where this will edit your profile. So if I edit my .profile file, which this is a script that runs every time you log in, you can see down here I'm basically setting the path to include this little ESP Open SDK inside of here. So this will mean that tools can access the ESP compiler in the path. And then after you modify the profile, you just want to log out and log back in. So this mentions exit and then Vagrant SSH back in, so that you can see the path is there. So okay, so that's done. I've already done that ahead of time. And then compiling the MicroPython firmware, it's pretty easy. So again, the Vagrant image I'm using, it automatically clones the repository, and the repository for MicroPython, it's on GitHub, and I'll put a link in the description below. But it's basically all the current state of MicroPython is here in this GitHub repository, and it supports all kinds of different platforms. So you can see ESP8266 is one. I think they have CC3200. There's the STM, the ST microchips. That's the one that the Pi board uses. I believe the ST micro, the ST HAL version, is the most complete version, in that it has, I think, the most stuff implemented. But after this ESP8266 Kickstarter, it wouldn't surprise me if the ESP version also becomes just as complete as the other versions. They also have a version that can run just on a Linux machine, like not necessarily an embedded machine, and I think this is good for like testing and stuff like that. And so lots of cool stuff in here. But so that's where the code comes from. And then the Vagrant script, it'll automatically sync it, but there's a little bit of setup you need to do, and this is one new thing that I just noticed. You have to run this get submodule update command. This will pull down some dependencies. So the MicroPython repository also has some sub-repositories you have to pull in, and I noticed it was for some crypto stuff, so I'm betting for like SSL support and stuff they need to pull that in. So basically you just want to go into the MicroPython folder, and I'll run these commands again because it's actually really easy. And it's a quick compile. Like, it only took maybe less than a minute for MicroPython to compile. So I just ran the git submodule command. It didn't do anything for me. That's because I've already run it. But when you run it, you'll see it pulls down a bunch of Git repositories. And then I want to go into the ESP8266 folder, and let's go into there. And I'm just going to do a make clean first, because this will delete any of the older versions that I had, or the previous one I compiled. And then just run the make command, and that will go through, and it's just compiling everything. And it's using the ESP8266 compiler, the one that we have in the path. And so it's just going through and doing its thing, and it's pretty straightforward. And it's a quick little compile. And then what this will spit out is a bin file. So it's just the raw binary data to run the MicroPython firmware on the board. And you can use a little tool to flash your MicroPython board, like the ESP8266 Feather Huzzah, or just a raw ESP8266 board. So it finished. And the important thing is it tells me it created the build firmware combine.bin. And so that's the bin file. And this is what we need to load onto our board, basically, to start controlling it. Now, to load this, in the guide I mentioned, basically you can copy the file out of your virtual machine. So I'm going to copy out the build firmware combine.bin, and I'm copying this to the /vagrant folder. And so if you're not familiar with Vagrant, it automatically will set up a little synced folder. So anything under this /vagrant path in my virtual machine will be copied out to my main machine, my Mac OS X machine here, into the same directory as the Vagrant file. So, and it goes vice versa, it goes two ways. So if I copy a file in there from my Mac, it'll actually sync it over to the machine. So it's a good way to move files in between the two systems. You can also use like SCP and any other copy tools that you want. But this is easy enough. So so I'll copy the file out, and then I'm going to exit out of the virtual machine. So just type exit, and now I'm back onto my Mac OS X machine. And if I look here in my directory, you can see here's that firmware combined file. So that's what I need on my machine here. And then I've got my board over here, and it's plugged into my Mac. And if I look at the serial ports, let's see, it's dev tty.star. Let's look at. Then we'll see I've got a slab USB to UART. And so for the Feather Huzzah boards on a Mac, this is the type of device you'll see, this slabs UART. That's Scilabs, basically. There's a little Scilabs chip on here that does the USB to serial conversion, because the actual ESP module here, this kind of large silver thing, it communicates over a serial connection. And so you need some way, like if you just get a little raw ESP8266 board, then you've got to have like a little FTDI chip, or some kind of UART to USB chip, or you could just talk directly to the UART, like if you have a Raspberry Pi or something like that. So that's the port that I need. And then to actually load this, on the page here I talk about how to flash it. So there's a piece of software called ESPtool.py, and it's from this GitHub repository here, and great little Python script that can just do all the different kind of flashing and firmware updates for an ESP board, and it's pretty easy to use it. So I'm gonna to install it, basically you clone the repository, which I've already done on the machine here, and then inside of that ESPtool repository, you just want to run sudo python setup.py install, and that will globally install the ESPtool.py on your machine. And on Windows, you don't actually need to give the sudo command. You just want to make sure that like Windows, I think the Python stuff can be installed without having to elevate to admin. But you want to run the install, and then after you've done that, you'll have this ESPtool.py command in your path. So if I run ESPtool.py //help or --help, this will tell you, okay, first of all, it shows me that the tool exists. Well, that's a good check, that it got installed. And then these are all the little subcommands that it has for this. So let's go back to the directory where I had that firmware combined. It's in the ESP8266 VM, or the Vagrant repository. So I've got the firmware combined, and then to load this up on the hardware, it's pretty easy. So I'll show you the command that I show here is basically you run the ESPtool.py. The -p option is where you point it at the serial port, so that dev tty scilabs. And then you can give a baud rate here, and this gives like a pretty fast baud rate. You give it the write flash command. You give it a flash size of 8 megabytes or 8 megabits. and then 0, this is where to start writing the binary file, and then the name of the bin file to use, the firmware combine.bin. And this changed slightly if you'd looked at this tutorial previously. Excuse me, I think before kind of some recent changes, you didn't need this flash size parameter, but I noticed that you do need this now. But one thing I'll show, and I didn't mention in the guide, but it's kind of handy to know, you can just erase the firmware on the chip first using a little command from the ESPtool.py. So let's do ESPtool.py. We'll do -p to give to point it at my device. So /dev tty.scilabs usb to uart, and then just do the erase_flash command. And so let's run this. Let's see, what did I do here? Oh, I misspelled it. SPTool. Nope, that's not it. Let me go back here to that, delete that. Okay, so it's going to connect, and it erases the flash. And so now this chip, there's nothing on it, so it's not going to do anything. It's just good practice to erase the flash before you program stuff, because maybe if you don't erase it, maybe you have some weird bad state, and then you load new firmware, and it's like, crap, it's not working. What's wrong? Well, that old state might screw it up. Okay, now to flash the chip, let's do ESPtool.py -p dev tty slab, so point at the device, and then I'm going to copy out the rest of this command here. So we'll do the baud and the flash size. So let's paste this in, and it's going to use the firmware combine.bin. So I'm in the same directory as that file. So we'll run this, and it's going to connect in. It looks like it erases the flash itself. And now it's writing it out, so it's you might be able to tell there's a little blue light right here next to my finger that's flashing, and so that's just telling you there's some activity. So it's doing its thing, and okay, so it just loaded up the firmware. And now to use MicroPython. So I guess the most full-featured way right now is they have a little Python console that you can access over the serial port. So you want to open your serial port at 11.5.200 baud. And I'm going to use the screen command on OS X. If you're on Windows, I think in the guide I mentioned you can use PuTTY or any kind of a program that can access a serial port. You can use that. So I'm going to do screen and dev tty.scilabs and 11.5.200 baud. And you open it up and it's like, okay, there's nothing. Now if you hit enter, that'll kind of show you, okay, now I'm at a little a console here where I can type things. And if you've ever run just the Python command itself, you'll see this is really similar. Like here, if I go to my Mac and if I just run Python, this is what's called the Python REPL, the read, evaluate, print loop. And it just lets you run Python commands. So I can say print hello world, and it's going to print it out here. So that's the cool thing about MicroPython, that they're trying to make it feel a lot like normal Python. So I can actually do the exact same thing here. I can say print hello world, and look at that, it prints it out. And this is running on this little ESP chip. So this I forget what they run at. I think it's like 80 megahertz or so. It's not super fast. Certainly not as fast as this quad-core i5 Mac that I'm running on. But it's really cool. I mean, it's the exact same Python syntax. I think stuff like string formatting works fine. Like let's try hello 0.format, and let's put in world in there, and let's see if this works. So yeah, that works. So this is much easier than writing C code and SN printf and all those kind of things. It's Python, and it's really cool that it's interactive. You got this loop, or you've got this REPL, so you can do all the looping constructs and things. So like for I in range 5, and then notice it's auto indenting. That's pretty slick. And we'll just print out I, and then have it go. And so look at that, it just looped through, printed out 4 things. So that's pretty cool. It's a little Python board. You just connect to it over the serial port. And then there's more functionality built in though, and it's a little tricky to find this yet because it's still early on in the development of this, and so they don't have super slick documentation for this stuff yet. And I think honestly the best documentation is probably crawling through the source code. But it's not as scary as you might think to look at the source code for this. Like if we go in, this is the MicroPython source code. We'll go into the ESP8266 directory, and it's all written in C. Some of it's also written in Python, and it's very similar to if you've used C extensions in Python. how you create a C extension, like you implement all of your Python functions as C code. And so you can go through and you can see like all these mod files. These are the different modules you can import. And so there's this mod PYB module. And so this has some functions here for controlling the GPIO. And so what you can do, so to toggle GPIO, you want to import the PYB module. Now one handy thing, unfortunately I don't think it supports docstrings. So like in Python you can do help PYB and that would print out, here's info or the docstrings on this. But the dir command in Python is pretty handy. So the dir command shows you all of the things on an object. So like if it's a module, it'll tell you all the functions inside of there and all the objects. Or if it's a class you're looking at, it'll tell you all the functions and stuff on it. So inside the PYB module, I can see there's an info, millis, elapsed millis, micros, all these different things. Now there's this pin class, and so that's actually the class that lets you control GPIO. And so, for example, this LED, I have it connected to pin 16, and then that's through the longer leg of the LED. And then the shorter leg is going down through a resistor, a 560 ohm resistor, down to ground. So that's just to limit the current through the LED. And you can see it's turned on by default. I think that's probably just the firmware just happens to turn that pin on as an output. But let's control that pin ourselves. So we'll say pin equals pyb.pin. So this is making an instance of the pin class. We give it the pin number, so 16, and then the type of pin. And so this is it an input or an output? Input with a pull-up resistor, it's just like in the Arduino world. So I want to do pyb.pin.out. And this slightly changed in the tutorial. I mentioned it used to be out pp for out push pull, but it looks like they changed that recently, so it's just an output. So we do that, and now I can do pin.value, and if I say 0, then look at that, it turns off the LED. And if I do pin.value 1, then it turns it back on. So pretty cool, pretty simple. And I think I can even do like true and false in here. So if I say like pin false, then yeah, that turns it off. So easy way to control that pin. And if I want to make this flash, for example, you can import the time library. And this one big thing I should preface is that this is MicroPython. It's not full Python. So, you can't like import the JSON library and have a little JSON decoder. At least I assume you can't. Maybe they've implemented that. But, all the standard libraries in Python aren't all implemented here. They're trying to be very close. And, it wouldn't surprise me if, given some time, they'll probably be very close to implementing a lot of the libraries. But I'm sure there's some libraries that they just won't be able to import or to implement because they're just too complex. But the time library is there, and the time library is useful because it has the sleep function that lets you delay for a period of time. So if I want to blink the LED 5 times, I can say for I in range of 5, and then let's say pin.value 1 to turn it on, and then time.sleep we'll say half a second, pin.value 0 to turn it off, time.sleep half a second again, and then let it run. So you can see this kind of flashes, and it should flash 5 times and then be finished. So yeah, that's it. Now one thing is that I'm in this console, and so if I did like an infinite loop, that's it. Like my code's not going to run anymore. I'm not going to be able to import more stuff or control it. So just something to be aware of. Now there is support in MicroPython for a basic file system. But it's very early development in the ESP port, and it was crashing when I tried to use it. But eventually, from what I understand, you'll be able to create a Python file, and it looks like if you create a boot.py file on the board, and right now you have to do it using the Python code, but if you create that file, then from what I understand, it will load, when the chip boots up, it will look for that file and start running it. So you can have, here's my script that runs on boot that like implements, my GPIO access code and all kinds of fun stuff. So that's the PYB library. I think as far as I understand, it only has basic GPIO access. Oh, it can also do reading pins. So we'll say pin 2 equals pyb.pin, and pin 12 is this red wire. And right now I have it connected to nothing. It's just floating. But if I move it between ground and 3.3 volts, then I can test that it reads that as a digital input. So I want to first say this is a pin.in type, so it's an input pin. And now pin 2, if I just run the value function. It's going to read it and get its value. Now it's floating right now, but I'm going to connect it to ground, and we should see that it comes back with a value of 0. So yeah, it's 0. And now if I connect it to 3.3 volts, which is down here, and I do the same thing, then I get a value 1. So it's, basic digital input. Pretty easy to use. You can do lots of things with this though. Like if you have a digital sensor, like a door open or close sensor, you could read this and have that. Now I also mentioned in the guide you can start accessing Wi-Fi. So they have an ESP class, and you can connect to your Wi-Fi SSID, and they have a super basic socket interface. Now this was as of a year ago, so I'm betting a lot of this has changed since then, and I don't think I'm going to get into it in this little video right now, but it's something to check out. So if we look at their source code, I'm just kind of curious. So like here's this mod ESP.c, so this is where they've implemented their ESP8266 specific stuff, and so this is where all of the functions are. So this is like, it looks like they have a socket class, and so this is where it can construct the socket object. Let's see. So yeah, it looks like it's got, you receive data, you get a callback. When you send data, you disconnect. They've got functions for that. So there's a lot of functionality here, and I'm sure it's going to keep getting fleshed out as they go with this. So it's pretty cool though to just have some of this functionality, and let's just kind of look around and see what else they have. So like I see here's PyB I2C.c, so maybe they have some basic I2C support in here. So let's see, like if I import PyB I2C, oh, maybe that's not it. Maybe it's PyB.I2C. Let's see if that's it. Oh, that's not it. So I don't know. You have to dig in more and see, exactly how to import some of this stuff. And like I said, like this is pretty much kind of alpha level. At least they've said in the firmware. Like it's just until the last month or so that they've really started to do a lot of development on this. So it's not super polished. It's not just ready to go. Like if you're totally new to this, like you're gonna have to dig in and learn a little bit. But it's, I think, a really cool base that they've got so far for this. I mean, it's impressive that they've got enough implemented that you can connect to this board and just start talking Python to it and do basic Python stuff. So really good base and good start for stuff they have. So okay, the other thing that I wanted to jump into. So one neat thing, I got this email here, and so I backed the Kickstarter, and I think as a part of backing the Kickstarter, they sent out some early alpha firmware of some of the neat features that they're still in development with. And one cool thing that I'll show that they have a demo of is a web REPL, where it's a web page you can connect to that will actually give you this same little Python console, but from a web page. And that's really cool because I can see, eventually once they've finished implementing all of this, it will be really impressive where you can boot up MicroPython, connect to it. It can actually create an access point, connect to it from like a little tablet, and then just see a little Python console and start typing in code. I mean, that's really powerful. I think that's going to be really cool for people that want to start, get started with like physical computing and stuff like that. I'm really, really looking forward to what they do with this. And just in general, super impressed. Like, hats off to the MicroPython guys. I think Damian George is the kind of main contributor to it, but lots of other folks have contributed. And they've run an excellent Kickstarter from what I've seen, and they've got an excellent piece of software here. So it's definitely worth checking out. So okay, so this tells me they sent me a special firmware, and I tried, I don't know where the code for this firmware is. It might be in like a private thing that they're still developing, and then they'll push it onto GitHub. Because when I compiled the latest stuff from GitHub, it doesn't run exactly the same as the firmware they sent here. So this might be like a secret, only thing that only the Kickstarter backers have right now. But I'm sure eventually it's going to come down to everyone. And so I don't think I can give out this firmware, unfortunately. But I'll show you what it looks like and what you can do. So okay, so let's quit out of my connection here, and let's go in and let's see. Okay, so I've downloaded this firmware. So they basically gave me a bin file and some commands on how to flash it here. So let's go to my download directory where I have this. Oops. And it should be the only bin file in here. Yeah, it's this MP ESP8266 firmware. And the first thing they say, you want to erase the flash memory, because when it boots up on a totally clean image, it will launch a little wireless access point you can connect to. So let's do esptool.py -p dev tty, point at my device and do erase flash. So I'll erase the flash for the board. And just to test, so I'll show you if I try and connect to the board now, if I run the screen command, dev tty.scilabs, this shouldn't connect. So we'll see it connected, but there's not, like, I'm hitting enter, I'm typing stuff, I don't see anything. So there's nothing running on this ESP board. It's like basically I just connected to the serial to USB chip. So we know it's erased. And then to flash this, they give the command here, which is exactly the same as flashing it on from the guide that I mentioned here. And they actually give two options. For some boards, you need to specify this -fmdio option. I think this is just like how it triggers the board to go into the flash programming mode. And luckily for the little Huzzah board, you don't need this option. There's a certain way that it toggles, I think the DTR line, and then that triggers the ESP chip to go into the programming mode. If you weren't using the Huzzah Feather Huzzah board, and you just have like a raw ESP board, or the older Huzzah board that's not the Feather, that doesn't have the USB to serial chip, you have to like hold down the reset button and press another, like there's a GPIO button. There's a weird little toggle thing. That's what I love about the Feather board, is that that's all integrated in here. You don't need to worry about it. It's almost like using a normal Arduino. So okay, so let's run this command and load the firmware up that they gave us. Oops, let me copy this out again. Yep, that's the command. So copy, and let's paste this in. And this should, oh, let's see, what did it's mad about? Oh, it's probably something weird about the formatting. So let's just type it in manually. ESP tool, give it the port. Oh, duh, because I don't have dev tty USB. All right, so let's do the Scilabs chip, and then the baud is 4060800, or no, 4600800. So pretty fast baud rate, and write flash, and then flash size. Oops, 8 megabits. Okay, the offset, and then the firmware. So okay, so now we're going to connect, and it's going to flash the firmware, and we'll let this thing go. At least it should connect. Uh-oh, didn't connect. I'm going to unplug and plug back in the board, because I might have done something weird when I tried to connect with that screen connection. So okay, let's just make sure that we still see the chip. So dev tty star, and let's see all these devices. I don't know why OS X creates all these TTY devices. It's always really annoying. So okay, yeah, so it's there, tty.slab. So okay, let's try our command again, and let's see. So this should hopefully connect. There we go. So racing flash, and it's writing the firmware. So again, this will take a second. And the cool thing is now, so after it writes this, I'll jump to the full desktop, and we can see it will actually create a little wireless access point that I'll be able to connect to from my Mac. And they don't have a web interface built yet, but they've got an early start to it that I'll show you we can play with. So okay, so that flashed the firmware. Now I'm going to switch to the main desktop view. So let's jump to this. So okay, so there's Wirecast, and we'll just kind of move that down here. And up here, this is on my Mac. I'm going to turn Wi-Fi on, and it's going to scan, and it's going to look for all the devices. And now look at this. There's a MicroPython device. So let's connect to this. And then the password in the email, they said it's all lowercase, MicroPython, and then the N at the end is capitalized. So let's see, I'll just show the password. So MicroPython. So let's join this, and it looks like it's joined. So yeah, I'm connected here, and I think if I, there's a certain way, yeah, if I hold Alt and I click this, it shows me that, okay, I'm connected to this device. And so, okay, so let's go back now, and we'll go back to the main kind of view here. And so, okay, so that's cool. So the firmware, you know, I'm connected to the ESP, it's running a wireless access point. Now to enable the web REPL, there are a couple things I need to do. So I need to first connect to the board over the serial port, because you have to run a little script to kick it off. And like I said, this is all alpha level stuff. Like this is all proof of concept almost. You know, this is not the way the final thing is going to be, I bet. So I'm going to connect to the board. So let's go dev tty.scilabs and 115200 baud rate. So you know, I'm back in the web REPL, and then I need to import web REPL 2, I think they called it. And so this imports their little web REPL thing. And I believe it's a WebSocket protocol that they're using to communicate with the board. Now this isn't going to return. It's actually, it just runs forever now. So I just need to leave this open and running. And now they say there's a little repository to clone that has the code for their web REPL. And you need to clone that repository, which I've already done. And then you just open it up in a browser. So let's open up the file that they give. And let's go into the repositories here. And it's the web REPL, and it's this webrepl.html. And so I've opened this up, and let me enlarge this a little bit. So we'll zoom in a few times. And oh, let's see, let's go back one out. Okay, so I'm gonna hit the big connect, and hopefully this, and before, like once you run this, you also need to be connected with your wireless network to the ESP board. So like that first step that I did, I connected my Mac. And now in theory, this should connect. And hey, okay, connected it says. This is cool. Now let's see what we can do. So like if I say print hello world, prints it out. That's cool. So, you know, this is just from this web page. They've got a little Python console. Let's try to access the GPIO again. So let's import pyb, and then let's do pin equals pyb.pin, pin 16, that's LED, and then pyb.pin.out. Okay, that's cool. Now pin, let's do value 0. That's cool. Look at that. Turned off the LED. Let's do value 1 and watch the LED. Turns it on, so that's cool. Let's do for I in range 5, 6. What the heck? Oh wait, let me import time first. Import time. Now let's make it blank. So for I in range of, let's do 10 times. And let's do pin.value 1 time.sleep. We'll make this faster. Quarter of a second. Pin.value 0 time.sleep. Quarter of a second again. And that's all I need. And now look at that. We're blinking 10 times quickly. So this is pretty cool. Like I'm very impressed with what they've got. And this is all, they say alpha level stuff, but it's pretty cool. I think you can kind of see where they're headed with this. I can imagine that, maybe the default firmware, the first time it loads, will make a little wireless access point, and maybe it will automatically run this web REPL, and then you can just connect to it and open up a web page and just get started typing Python. Like this is really cool. Like you don't need to install anything. You just start typing code and go crazy with it. I can imagine, maybe they think about exposing the file system. Maybe I can like drag a Python file onto here or something. Lots of cool things they can do with this. But really cool to see, where they've come, and or how far they've come in a year since when I first looked at this. Lots of cool stuff that they've got. So that's basically what I wanted to show in this stream. Just highlight the MicroPython project and show that it's doing some really cool stuff with these little chips. It's definitely worth checking out. And again, I'll put all the links in the description to both the micropython.org website and then the Kickstarter they had. And the Kickstarter is over, so I don't think you can really get into on it. But because they hit all of their funding goals, they're doing all this development in the open on GitHub. So you'll be able to use this code even if you couldn't contribute to it initially. But I think that's all I wanted to do. So let's see. We'll jump back to the main shot here. And if anyone has questions, maybe throw them into the chat, and I might be able to answer them. But yeah, I think I'm hoping to maybe come back in a month or so, and we can check back up on it and see what they've done. But like I was showing before, it looks like they're going to implement a lot of different libraries and things to make it easy. I think I saw they mentioned they're going to implement an MQTT library, so you could probably talk to different IoT services. Maybe do like some Adafruit IO stuff for this. So. Let's see, a question. Do you think there will be a sleep mode to save power? Good question. Actually, let's look and see what they have in their source code, if they have anything for sleep yet. Because, yeah, that's one big thing when you're building a little embedded device, especially when you want to do low power. You don't want to run your CPU at full speed all the time, because, like, let's say you have like a little device that's just like reading a sensor and sending the value to like a web service. For all that time that it's not reading the sensor, you don't need to run it at the full speed. And so if you can put the processor to sleep, then you'll save a lot of power. You can run a lot longer. But yeah, for things like the ESP, you need to, they have certain APIs, I think, in their framework to put it into a sleep mode. But yeah, let me go back and let's look at their GitHub repository here and just see. So let's see. I'll switch back real quick to the main view here. So let's go to MicroPython GitHub, and let's see if they have anything implemented here for sleep. So let's go to the ESP, and I'm betting, let's see. So let's see what modules they have. So they have the OS module, time module. Those are kind of standard ones. Looks like there's a UART, SPI, RTC. That sounds kind of promising. Maybe there's like a real-time clock. Yeah, it looks like, oh, this is probably just for like talking to an RTC. Let's see, PWM, it's pretty standard, pulse width modulation, pin control, I2C, ADC, that's analog digital converter. So yeah, so I don't see much in here. Maybe in this ESP module we might have something. Let's just search for like sleep if there's anything in here. Oops, I want to do control F. There we go, sleep. Oh, sleep type, interesting. Maybe there is some. Oh yeah, here we go. ESP deep sleep. So let's try this. Let's see. I'm on the board right now, I think. Oh wait, no. Oh, interesting. It looks like the board just crashed. So I don't know. Maybe there is sleep mode. It's something I'll look at, and maybe in a future video we can see. But there's this deep sleep function in here. In theory, if you import the ESP module, then it should have a deep sleep function in here, and it looks like it takes. Let's see, what argument does it take? So it takes an integer argument, it looks like, which I'm guessing is probably the number of microseconds to sleep for. So I don't know, maybe worth trying it out. What's the worst that can happen? You crash the chip for it. So, but yeah, I think that's it. I think I'll wrap up the stream. So let's see, we'll jump back to the main shot here. But yeah, subscribe to youtube.com/Adafruit, and you can see this and a lot of other cool videos. Subscribe to twitch.tv/Adafruit, and you can watch me do this live and lots of other live videos. I like to do a Friday live stream on Raspberry Pi stuff, and actually this week, little programming note, I'm going to do my Friday stream on Thursday, just because I'll be out of town on Friday. So I'll do something, and I'm going to start a new little series of things. So I just wrapped up a 4-part series on building a Raspberry Pi Internet of Things device. So I was thinking I'll start a new little series, and it'll probably be another 3 or 4-parter on having a Raspberry Pi talk to Wi-Fi boards. So boards like the ESP8266, the Wicked board, and all kinds of other little things that we have. Because it's not immediately obvious. You get this little Wi-Fi board, and let's say you want to have it send like sensor readings to a Raspberry Pi. And so, I want to look at like basic socket programming and like network tools and things. So, I'm hoping by the end of it to maybe do a neat little project of like have like some ESP8266 boards that are sending sensor data to a Raspberry Pi and maybe showing it on a dashboard, that type of thing. So definitely tune in Thursday. I'll do that, and it'll go up on YouTube also later. So yeah, subscribe, like, comment, do all that fun stuff. Thanks a lot for watching, and I'll see you guys Thursday. So take it easy. From Tony from Adafruit.